Hi to everyone. This is Dr. VNSR Venkateswara Rao, working as an Associate Professor from the Department of Chemistry in Institute of Aeronautical Engineering, Hyderabad, Telangana. So today I would like to give one of the important topic related to the analytical chemistry. So that is classification of the Titrimetric reactions. So this is also called as Volumetric reactions. Why? Because this is based on the volumes of a sample. So that's why this is called volumetric reactions or Titrimetric reactions. So before starting the session, first of all, we see what are the topics covered in today's section. So there are mainly 4 types of the volumetric reactions are involved. So the first one is the neutralization reactions, and second one is redox reactions, and third one is precipitation reactions, and fourth one is complex formation reactions. Okay, so there are totally 4 types of the reactions involved in the types of the Titrimetric methods. The first one is neutralization, and second one is the redox, and third one is the precipitation, and fourth one is the complex formation reactions. So depends upon the mechanism involved in between the reactants to give products. That is nothing but a chemical reaction. Now let us explain the one by one. The first one is the neutralization reactions. So the first of all, we see the classification of the Titrimetric reactions. The important and commonly used volumetric reactions may be classified in the following 4 classes depending upon the type of the reactions taking place during the titration. So depends upon the mechanism involved between the reactants, we can classify the types of the volumetric reactions. For example, consider a chemical reaction. A plus B gives rise to C plus B. So the reaction mechanism involved in between the reactant molecules A and B, we can finalize the type of the chemical reaction. That means if the resultant products are the neutral state, so that are called neutralization reactions, and involved reactants are a oxidant or reductant to give a redox reactions, that is called reductometric. And also third one is if the products are in the form of precipitate state, that are called precipitation reactions. And finally the products are present in the complex state, that are called complexometric reactions. So that's why the type of the reaction involved in between the reactant molecules, we can classify or finalize the type of the chemical reaction. So that's why these are mainly depends upon the 4 classes depending upon the type of the reactions taking place during the titration, during the chemical reaction. Okay, the first one is the acid-base reactions or neutralization reactions. So from the title we understood that the reaction takes place in between acid and base, and the resultant compound is the neutral medium. So that means the reactants A plus B gives rise to C. So that means these two reactants are, one is acid and second one is base, and final resultant product C is in the form of neutral medium. So the reactant A is acid medium and reactant B is base medium and product C is neutral medium. So that's why this is called as a neutralization reactions. So depends upon the type of the chemical reaction, it is finalized by the acid base or neutralization reaction. So in these reactions, an acid and a base react with each other and both are become a neutral compound So in the chemical reaction way, we visualize the reaction. So that is nothing but one acid reacts with the another base to give a neutral compound. So that is called neutralization reactions. So depending upon the type of the acid and base react with each other in neutralization medium, these are further classified into 4 types. One is strong acid reacts with strong base, and second one is weak acid and strong base, and third one is strong acid and weak base, and fourth one is weak acid and weak base. So there are 4 types of the categories: strong acid and strong base. That means hydrochloric acid with sodium hydroxide. Okay, and second one is weak acid, strong base. Weak acid means acetic acid and sodium hydroxide. Okay, that is the second category. And third category is strong acid and weak base. That means strong acid means hydrochloric acid plus ammonium hydroxide. Ammonium hydroxide. Hydrochloric acid plus ammonium hydroxide. So these are the examples for the previous three titrations. But the fourth titration, nothing but weak acid and weak base cannot exist. Why? Because we can determine the equivalence point of this reaction. Equivalence point means the reaction is just complete. So that is called as the equivalence point. Out of four categories, we cannot determine the exact equivalence point in case of weak acid and weak base. So that's why we consider the only three types: strong acid and strong base, in between hydrochloric acid and soda hydroxide, and also weak acid and strong base, acetic acid and soda hydroxide. And third category is strong acid and weak base. Strong acid means hydrochloric acid and weak base is ammonium hydroxide. So these are the four types of the reactions involved in the neutralization reactions. So by taking the example of the strong acid and strong base. So strong acid is hydrochloric acid and strong base is sodium hydroxide to give a compound product sodium chloride salt. That is also neutral, and water is also byproduct. This is also neutral. So by taking the products, both are neutral compound and these are produced by taking a acid and base. So that's why these are called as a acid-base reactions or neutralization reactions. Acid-base reactions are neutralization reactions. And now we see what is the mechanism involved in this neutralization reactions are nothing but, since in aqueous solutions acids and bases ionize to give H plus and OH minus ions respectively, which is then reacted to form a feebly ionized water molecule. And these reactions are merely combination of H plus and OH minus ions to form a neutral water. So according to the definition, the substance which gives a H plus ions in aqueous medium, that is called acid, whereas the substance which gives a OH minus ions in aqueous medium, so that is called base. So from the acid we observe HCl, it will be dissociates into H plus and Cl minus ions, and second compound NaOH. So this will be dissociates into Na plus and OH minus ions. Now we see the products. Products are NaCl and water. Okay, so these compounds are produced by combination of this cation and anion to give a NaCl, Na plus and Cl minus, and these feebly ionized H plus and OH minus ions combined to give a water molecule, H plus and OH minus. Okay, so depends upon this type of the mechanism involved in the acid base or neutralization reactions. So that's why the H plus ion coming from the acid and OH minus ions coming from a base to give a water molecule. And the titrations based upon this neutralization reactions are called as a neutralization reactions or acid base reactions. Neutralization reactions are acid base reactions. That means the titrations involved in between the acid and base to give a neutral compound. So that is called neutralization reactions or acid base reactions. Okay, so this is the explanation about the first type of the volumetric reactions, nothing but neutralization or acid base reactions. Now we move to the second one, that is called redox reactions. So oxidation or reduction reactions and redox reactions. So because the title is involved, the reactions mainly involves the oxidation and reduction simultaneously. That is called redox reactions. Now we see the definition. In such titration, oxidation, loss of the electrons, and reduction, gain of the electrons necessarily occur together, and one substance being oxidized and another substance being reduced. So that is called oxidation and reduction reactions. So basically oxidation means loss of electrons and reduction means gain of electrons. So that is called redox reaction. So for example, if you consider as a dichromate, potassium dichromate K2Cr2O7. Okay, now we calculate the what is the oxidation state on the dichromate. So for example, in the potassium it is belongs to first group, so +1, and chromium is determined X, and the charge on the oxygen is -2. So +2 plus 2x minus 14 is equal to 0, and 2x minus 12 is equal to 0. X is equal to get 6. So the oxidation state on the chromium is 6. Okay, and this is the example for a oxidant. And now we see the example for a reductant. Reductant means the best example is a Mohr's salt. Mohr salt means the iron is present in the +2 state. So that's why this is called ammonium ferrous sulfate. Now we see the reaction between the chromium 6 and ferrous salts. So that means chromium 6 reacts with the iron 2 to give a compound like chromium 3 and iron 3. Okay, chromium 6 to chromium 3 is reaction takes place, and iron 2 to iron 3 reaction takes place. So from chromium 6 to chromium 3, what happens? Reduction takes place. And from iron 2 to iron 3, what happens? Oxidation takes place. So initially the chromium 6 is coming out from a potassium dichromate. It is a example for a oxidant. Okay, and iron 2 is coming out from a Mohr salt. And it is the example for a reductant. So that means always the oxidant which is participates in a reduction, and the reductant is always participated in a oxidation. So that is the main principle involved in a redox reaction. That means the reaction simultaneously takes place both oxidation and reduction. So that is called redox reaction. And we see the process, that means loss of the electron takes place in case of the oxidation. Oxidation means iron 2 is raised to iron 3, that means by the loss of the electron. So that's why this is called iron 2 is raised to iron 3 by the loss of the electron. So that's why in this case we observe there is a releasing of the electron. So releasing of electron means loss of the electron will be takes place. So this is the example for a oxidation. Whereas in the case of the reduction, so chromium 6 by gaining the electrons, 3 electrons is raised to chromium 3. So that means the oxidation state will be reduced from chromium 6 to chromium 3 by taking the electrons. That means gain of the electrons. So that's why this is the example for a reduction process. That means the reaction simultaneously takes place both oxidation and reduction. So that is called redox reaction. So in such titrations, oxidation is nothing but a loss of the electrons takes place, and reduction is nothing but a gain of the electrons necessarily occur together, and one substance being oxidized and another substance being reduced. So the oxidized substance is nothing but a Mohr salt involved in the reaction of the oxidation reaction, and whereas reduced substance is nothing but a potassium dichromate which involved in the reduction process. So reactions are described as oxidations are usually those in the which of the oxidizing agent. So what are the examples for the oxidizing agents? Nothing but strong oxidizing agents are potassium permanganate and potassium dichromate, acidic potassium dichromate. And the oxidation state of the manganese in potassium permanganate is manganese +7. and the oxidation state of the chromium in acidic dichromate is chromium plus 6. Okay, and the iodine and copper also taking the examples for a oxidants, and from the forms a standard solution, while in the is classified as a reduction as a standard solution of a reducing agent. So the reductants are the examples of the reductants are the ferrous salts like ferrous ammonium sulfate and ferric ammonium sulfate, and also oxalic acid, and also arsenic oxides and thiosulfates and iodines, etc. All of these comes under category of a reductants. So for example, consider the reduction of potassium permanganate by ferrous sulfate in acidic medium. So this is the permanganate ion coming out from a potassium permanganate KMnO4, okay, K plus and MnO4 minus. So this is the manganate ion reacts with the acidic medium, that means 8 moles of the H plus ions with 5 moles of the ferrous ions to give a manganese plus 2. That means manganese plus 7 changes to manganese plus 2, manganese plus 2, and iron plus 2, and iron plus 2 changes to iron plus 3. So that means in the previous reaction it is observed as a reduction, and from iron plus 2 iron plus 3 nothing but a oxidation. That means the reactions simultaneously takes place, both oxidation and reduction is nothing but a redox reactions. Okay, so the reaction simultaneously takes place both oxidation and reduction. Hence, it is proved in the by taking the example. That means manganese ions converted to manganese plus 2 ions, that is called reduction, and iron 2 ions converted into iron 3 ions, that is called oxidation. Okay, and finally it gives a 4 moles of water. So entire reaction will be takes place in the presence of acidic media. So titrations based upon the oxidation reduction reactions are called as a redox reactions. Titrations based upon the oxidation reduction reactions are called as a redox reactions. However, sometimes redox reactions are specifically named after the name of the reagent. For example, iodometric depends upon the iodine is involved, and permanganometric. Permanganometric means potassium permanganate involved in the chemical reaction, and dichromatic titrations. Dichromatic reactions means involvement of the potassium dichromate. So depends upon the type of the substance or the type of the compound involved in the redox reactions, that should be finalized by the title of the chemical reaction. If iodine is involved, that is called iodometric. If potassium permanganate is involved in the reaction, permanganometric. If dichromate is involved in the chemical reaction, that is called dichrometric titrations. So these are the types of the redox reactions. So next, the third type is the precipitation reactions, and the condition for the precipitation reactions is one of the solubility product of the reaction should be less than the ionic product of the water. So this is the condition for a precipitation reactions. So precipitation reactions process of a volumetric analysis are based upon the formation of insoluble precipitates when the reacting solutions are brought together. Thus, when a solution of silver nitrate is treated with a sodium chloride or potassium thiocyanate solution, a white precipitate of silver chloride or silver thiocyanate is obtained. So, for example, the formula for a silver nitrate is silver nitrate, and it reacts with sodium chloride NaCl to give a precipitate like silver chloride. White Caridi precipitate is obtained, and the byproduct is sodium nitrate. So similarly, the silver nitrate reacts with the potassium thiocyanate KCNS formula to give a potassium thiocyanate, and byproduct is potassium nitrate. So these silver chloride and silver thiocyanate are example for a precipitate. In these two compounds, the solubility product should be less than the ionic product of the water. So because of this, white Caridi precipitates are obtained in the chemical reactions. These titrations are termed or named as a precipitation reactions. So titrations based upon the such reactions are called precipitation titrations, and sometimes the method is called after the reagent used. For example, titration involving the usage of the silver. Why? Because in both cases the silver is common, So it is represented by Ag. Ag means Argentinium. So that's why these reactants are called as a Argentometric titrations. That means the titrations involved the usage of or utilization of the silver nitrate. Silver nitrate compound is a one of the titrant. So that is called as a Argentometric titrations. So in precipitation reactions, the Argentometric titrations are very important. Now we explain what is the Argentometric titration. So basically it is defined as the involvement of the silver nitrate in the any chemical reactions, that is called Argentometric titrations. So Argentometry, it can be utilized for the determination of the anions which react directly with the silver ions such as halides, cyanides, thiocyanates, thiocyanates, arsenates, and phosphates. So by taking the examples of different anions, halides, cyanides, thiocyanates, arsenates, and phosphates. That means halides. Halides means like chlorides, bromides, iodines. All of these comes under category of the halides, and fluorides also comes under category of the titrations, and also cyanides, Cn minus, and also thiocyanates, SCN minus, and also phosphates. So all of these comes under category of the determination of the anions by Argentometric reaction with the help of the silver nitrate. And silver may also be determined in reverse mode. So that means the reaction takes place both forward and backward reaction. And there are so many indicators in the Argentometric reactions. The first one is the ferric column, and second one is the potassium chromate, and third one is the eosin indicators. So depends upon the type of the indicators, the name of the reaction will be finalized. For example, if you consider the ferric column in the titrations of silver nitrate with ammonium or potassium thiocyanate, that is called Wohlhart's methods. So this is the first method of the Argentometry, Wohlhart's method. That means the required indicator is ferric column, and the titration done in between the silver nitrate with ammonium or potassium thiocyanate compound. And second reagent, that means the second indicator is the potassium chromate indicator, especially in the determination of the halides. So this is done in between the silver nitrate and sodium chloride. So that is called Mohr's method. So Mohr's method means the required reagent, that means the required indicator is potassium chromate. And third one is the eosin method. So eosin method means used indicator is eosin, and it is especially useful for the silver nitrate with potassium bromide. So there are mainly three types of the indicators. One is ferric column, that is in between silver nitrate with ammonium thiocyanate or potassium thiocyanate, and second indicator is the potassium chromate indicator, silver nitrate with sodium chloride. That is called Mohr's method. And the third method is the eosin titrations. Titration takes place in between silver nitrate with potassium bromide. So for efficient precipitation titration, the following conditions must and should fulfill. That means the substance precipitate must be formed quickly. That means there is no time gap for the preparation of or formation of a precipitate. And the precipitate substance should be relatively insoluble substance and should be the only substance to precipitate on adding the reagent. That means the precipitation takes place by the addition of a reagent from the burette, nothing but silver nitrate. And the detectable change at the end point should be observable in the reaction. So that means the formation of the precipitate should be observed in the case of the end point of a chemical reaction. So these 3 points are very important. So first of all, the required formation of a substance, that is nothing but precipitation takes place quickly, and that precipitation takes place if and only if by the addition of a reagent from the burette, generally silver nitrate is added to a required reagent. And third one is the detectable change of the end point of the reaction should be observed in terms of a reaction. Okay, so these are the mainly 3 required conditions for the formation of a precipitate. Okay, now we see the fourth type of the chemical reaction, that means Titrimetric analysis, that is called complex formation reactions. So this complex formation reactions especially observable and for the determination of the hardness of a water, because the hardness of water is mainly depends upon the salts present in the ground water. That means the sample of the water which cannot give the lather with soaps because of the presence of the salts, especially the salts present in the water compound are calcium and magnesium. So this calcium and magnesium belongs to the second group of the periodic table, that is called alkali earth metals, and these metals are determined by the one of the complex reagent, that is called EDTA, chelating compound. So whenever these metal ions forms the complexes with the chelating agent EDTA to form a complex compounds, and that is called complex symmetric reactions. That means metal ions reacts with the EDTA chelating agent to form a metal with EDTA complex plus releasing of the indicator. So these metal ions are either calcium or magnesium from the sample of water, and this EDTA is called as a chelating agent. And this final metal EDTA is called as a complex. So this ion is called as a indicator. Okay, so these metal ions, either calcium or magnesium from the sample of the water, reacts with the EDTA chelating agent and to form a metal EDTA complex by the releasing of a indicator. So first of all, this EDTA is called as a polydentate ligand, ethylene diamine tetraacetic acid. Generally, the metal ions have a positive charge and these are ready to accept the electrons, and EDTA is comes under category of the ligand. Ligand means which is the substance ready to donate the electron pairs towards the other substance. So that means in this case the metal ions are required to take the electrons and EDTA is ready to donate the electrons. So that's why there is a complex compound formed in between the metal and the ligand. So that is called metal to EDTA complex. So generally the complexes are shown in the big brackets. Okay, and finally the releasing of the indicator will be takes place. Because of the formation of a complex, these reactions are called as a complex formation reactions, are termed as complex symmetric reactions. So these are the sustained reactions in which complex compounds are formed, and the titrations involved in the formation of a complex compound, complex symmetric reactions. The most important examples are titrations involving the use of the EDTA. EDTA means ethylene diamine tetraacetic acid. So this is the full form of EDTA, ethylene diamine tetraacetic acid. Okay, so the reactions involved with the usage of EDTA to form a complex compounds. So that's why these are called as a complex symmetric reactions. Complex symmetric reactions. So this is about the total 4 types of the chemical reactions involved in the volumetric reactions. The first one is neutralization, and second one is the redox reactions, and third one is the precipitation reactions, and fourth one is the complex formation reactions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.